All right, so today will be the last part about Linux, and then we'll transition into how to program in C. All right. Here we'll learn a concept that actually used everywhere, not just in Linux, but the assignment for regular expression will be in Linux. So the reason why we want to do this is it allows you to process string easily. Well, I guess not in many cases, not easily, but in a much more powerful way in Linux. How many people use the find features in like Microsoft Word and other things? Yeah, we all use it, right? So what if I can tell you that now when you find something, it always has to be exact match, right? Has to exactly go based on what you put in for like Microsoft Word. What if I tell you there's an option, right, that allows you to say, make it such that it cover more than one exact cases? For example, what if I want to match both version of the same verb, right? Because a verb can take two forms, the plural and singular form with S and without the S, right? What if I can search and cover both cases? So regular expression is actually designed for that. And to motivate it, we use the grep command to do this. Like we talked about the grep command really quickly last week, and we'll continue on today. Because grep does take regular expression as a keyword to search. And it has many variations. It allows just a simple search pattern with the basic regular expression. It allows extended regular expression with the dash E. So this would be a full-blown version of what we learned today. You can also use the faster version because when you have to search the entire directory, not just one single file, that can take a long time. You can use fgrep, which will restrict certain patterns so that it gets faster. You can also search inside a compressed file with cgrep, right? Let's say we have the file that looks like this, right? It's a text file. And what we want to find in this file is the word man, M-A-N. I want to be able to identify the lines that contain the word man. I can do something with that later. Now, if I type in grep in quotation man followed by the file name, it will basically read the file and print out just the line that has the word man in them. All right. Then there's an egrep, which is basically grep dash E, the same thing. This allows extended regular expression, which then allow you to be more flexible about the keyword you want to search. For example, in this case, I want to search for either the word family or the plural version of this word, families. All right. I can do this, grep dash E family, vertical bar, families, and the input file. So in this case, right, it will pick that line that has the plural version of my word family and print it out. So this concept is what is behind regular expression, which allow you to search for more than one specific pattern. And it's used, this is why it's so powerful, it's used in many other programming languages, including say Python, right? So you can use this trick to do a lot of fun. How many people heard about the word data science? So basically it's the science of how to, I guess, process data, visualize them, and use them, right? If you have these particular tools, you can play around with what you want to filter in, filter out to get the result that you want. I think one quick thing before we go, do you have a mask? Yeah, I do have a mask policy. So if you are in this room, you need to wear a mask. Anyone have a spare for him? So basically, regular expression, you specify what you want to search. Basically, think of it as a pattern matcher. Think of it as pattern matching. So the syntax determine what pattern you're looking for. All right, the syntax will determine the pattern you're looking for. And here's one example. Can you? Yeah. Here's one example. What we call anchor. Anchor is this hat sign and the dollar sign. This has to do with I want to search for a term that has to begin the sentence with this word, or the end of my sentence, my line, that line with this word. And here's the example. If I do the hat followed by the THE, it means that I want to just match when the line begins with the letter THE. And dollar sign means that I want to just match for whatever lines that end with this three letter END. If I do the combination of them, as you see in the third line here, it's the exact match. It means that it has to be the end in that line. That's it. If I don't have the anchor, it means any word that, well, not any word, basically that particular word at any position in that line will match. All right. You can also have the quantifier. This is different from the wildcard you saw earlier from last week, from 2 weeks ago. Quantifier talks about how many times this thing has to happen. Star means 0 or more. So ABC star means that I have the pattern AB followed by 0 or more C. AB plus means 1 or more. So it can be ABC, ABCC, ABCCCCC. Then you can use the curly bracket to specify the number of occurrences that should happen. So if you do ABC followed by curly bracket 2, it means that I want to find the pattern AB followed by exactly 2C. Like I can put in the range like this. This is more like 2 or more. 2 comma sign and curly bracket means that 2 or more. 2 to 5 means that I want between 2 to 5 for ABCC, ABCCCCC, it's fine. Anything less, anything more will not match. Then over here, what we've seen so far is just one single letter, right? So what if I want the pattern, for example, ABC, ABC, BC, ABC, basically a group of 2 letters. I can do A in the bracket BC. This parenthesis would group things together so that whatever quantifier come afterward apply for the whole group. For the whole group that you have the parenthesis around. All right. It also supports the OR operator. This means that once I have the OR over it, which is the vertical bar or this bracket, now it matches more than one pattern. A in parenthesis B or C means that I have the match for AB or AC because it has to start with the letter A followed by either the letter B or the letter C. A in the bracket BC apply same logic to the previous statement. The bracket that you see here, right? Usually we will use it for alphabet. For example, in the assignment task 1, we ask to search, basically not search, but you take in the input file and make sure you just print the line that contains small Roman numeral, any number that is lower than 500, right? This is a useful tool, this bracket, in combination with the grep command. It's going to be pretty useful for the first task. So the OR expression has multiple formats. You can do like bracket ABC. This is letter A or B or C. You can do a shorter form A dash C. It's the same A or B or C. If I want to, for example, represent a hexadecimal number, right? A hexadecimal number, it means that every single digit can be 0 to 9, then A to F. So I can do this. Sorry. A to F, lowercase, or A to F, uppercase, or 0 to 9. This will match any number but only single hexadecimal digit. What if I want to extend this? As many digits as I want. How do I do this? Can I use a quantifier for this? I can do this, right? The same thing. For every position, I can do 0 to F, right? And then I have plus at the end. It means I guarantee at least one digit. At least one digit or more. So it can be 0, 0 is fine. 0, 1, fine. 1, 0 is fine. F, F, fine. Anything more than F, like F, G, that will not match. Right? I can also pair up the, this is not the anchor, you see the hat sign here, but inside the parenthesis. The hat sign inside the parenthesis is the negation. It means not of that. So in this case, it's not the letter. Anything that's not letter. All right, it's not the alphabet from A to Z. Both lowercase and uppercase will match. You can also represent a class of character. For example, slash lowercase d is a single digit. Slash lowercase w is a word character, which means that A to C, basically, plus the underscore. So this would match A to C, both lowercase and uppercase. Also, the underscore is included as well. Slash S is for a white space character like tab, new line, or spacebar. Dot match any character. And if you have the uppercase, this is the not of the lowercase version. So the uppercase D is non-digit. Uppercase W is anything that's not a word character. Uppercase S is anything that's not a white space character. It's a not of the lowercase version. Here are some examples, right? In this case, I want to match what? Anything that starts with a pound and has, what is dot? Any character, right? And star means 0 or more. So anything start with a pound with 0 or more character. So things like this match. Things like this will also match. So what if I want to change this so that it matches any possible hashtag? What do I do? You want to match any possible hashtag, right? Begin with a pound. Any character, but has to have at least one. Be one single character or more, right? In this case, it will match data file 0, data file 1, data file 10, dot text. Remember, this is an escape character. Why do we have to escape the dot? It means that in this case, we specifically want the dot text. Dot in this case doesn't mean any character anymore. Dot in this case literally means I want the dot in my search term. I want to search dot. Has to be a dot. So in this case, anything that has the word data file with any digit dot text will match and will show up when you search. In this case, any what's it? Actually, let's do a 5 minute pause here, and you look at this 4 more example and see. Well, actually, just this two. This is simple. Anything start with the word rashada or just the exact rashada, right? But let's say this, what do they match? What is this and what is this? Now that we know the concept behind regular expression, what are the different commands that we can use to pair them up? The first one is the set command. Set stands for stream editor. Stream, basically we use this to represent infinite sequence of data, but in a layman term, for the purpose of this class, think of stream as text data or file data, like data in a file. It's a text editor that is not interactive. It's not Notepad, for example. It's not like Notepad. You open a file and you can type whatever you want. This is like you type in the command with the file that you want to edit. You hit enter, it processes the file with the command you want to edit. The edit will happen line by line by line. So basically you put in a command, it will go in, take one line, perform the edit. Take the next line, perform the edit. Take the next line, perform the edit. In other words, this is search and replace. Well, it can do more, but one of the most commonly used thing with the set command is, how many people use replace in Microsoft Word? We use it a lot, right? Same thing here. It allows you to do search, then replace with something else. So the way it works is the set follow with the option and the command. Command would be like, what do we want to do with this particular file? So one example, there's actually more. You can check what can it do through that link. But one of the most common commands that we do is something like this. Set followed by s slash the search term that you want to match. Then what you want to replace it with. Then the flag. One of the most common flag is G, which means that I will apply this everywhere in the file. For example, I can do this. It will then basically go in to my file, replace any occurrence of hi into hello. And one more trick that I'll show you is, let me open up the result. Right, so I have a file open through Vim, it's a text editor. Vim happen to have set built in. I can do this :S. This will match whatever line that contains the word test, change that word test into new. So if I hit enter, what's pattern on file? It's like right there. What? Oh, here. So see how it. See how it actually go and search for the pattern I want to test. This is only one line, so I have to go to the line I want to do. And then when I type in, right, in this case, you see how the match get changed to another word. So if I do it again, so it's matched this hi inside the word this. So with this is THIS, it found also hi in there. So it replaced that with hello. Then find two more hi in that line. So it do the same thing. That's one command. S is search and replace. Another command that's common is D. D is does nothing to replace. Basically, D with the pattern you want to check. If you found the pattern, you delete the pattern. You delete the pattern. The queue with the exit code will allow you to exit set with an exit code as well. You're not going to use it for the purpose of this class, but if you want to like string together multiple commands, one after another, and you are basically using set to modify something, then you can use this option to like exit with certain code as well. So here, given the same this text here, right? What I am doing, see the highlight part, right? Used to be a single man in possession of a good fortune must be in want of a wife. However, little known the feeling of will such a man. The old text used to be the word man. If I run this command with the file here, the word man changed to women. Now I can do something like this. Set with the regular expression, as you can see here. This is anything that ends with ing. Anything that ends the word with ing. Why is that the case? A to C uppercase, A to C lowercase, any number of these guys just have to end with ing. Ampersand is a special character that means that whatever you matched earlier. So let's say I have the word fishing. It will find that word. Ampersand will now be replaced to fishing. Then over here, what I'm replacing it with is not just the word, but I want to put parentheses around that replacement, right? Because I have the parentheses around it. It means that I will put parentheses around the matching word. So if I run this, you can see that I find the word single, right? Single is S-I-N-G. S-I-N-G, I mean, even though it still have more letters coming, the word ing is there, begin with something, right? So it put parentheses around, just around that part. So feelings, entering, surrounding here, right? As you can see, you can use this pattern to basically do something with what you found. Now that's a set command. The new command is another command that's useful is cut, right? Cut allows to extract a column of data. So the common option is -D, cut certain bytes from the file. -C, cut certain character from the file. -F, cut certain field from the file. And -D, cut based on the delimiter. Anyone know what does this delimiter mean? So, but you all use Excel before, right? Excel spreadsheet. Basically, if you want to represent a table, right? And let's say it's a table that has number in it, and 1, 2, 5. It is. I mean, how am I going to represent this in a text format? I mean, think of it this way: Excel has to represent this table, right? Somehow. What's the simplest thing I can do? Yeah, comma separate format or CSV. It means that whatever is in the same row, I separate them using comma. Whatever is in a different row, that's a new line. So this becomes 10, 1, 2, 5, and new line 6, 2, 2, 1, new line 3, 4, 7, 6. You can write your file this way, open that in Excel, it knows exactly where the number should go into. We can call the comma the delimiter. It basically allows you to separate items The cut command by default use tab. So in this case, sometimes there's also a file called tsv as well. So it is instead of comma separated format, this is tab separate format. So it's 10 tab 1 tab 2 tab 5. New line 6 tab 2 tab 2 tab 1. Right. So the way it works is you can do cut dash D with the delimiter. So like you want to separate it using certain things. Here's more concrete example. I want to use the delimiter, right? Notice how I said the delimiter has to be the comma. In this case, I said, hey, I want to use the comma as the way to separate the items. I want to cut using the column. And I want to retain column 1 and column 3. So if I do this, I will cut out B2. Because that's the second column that's gone. I want to keep column 1 and 3. Another pretty useful command is a translate command or TR. TR will translate certain character into another character. So here's an example. I can translate 1, 2, 3 into 4, 5, 6. So this is the input file, for example. It will map. If I see 1, I change to 4. If I see 2, change to 5. If I see 3, I change to 6. So when I do this 1, 2, 3, as we saw earlier, the character 1 now changed to 4. The character 2 changed to 5. The character 3 changed to 6. In this case, what it will do is whenever I see the character new line, I change to comma. In this case, that's a new line here. So instead of ABC new line 1, 2, 3, I will get ABC comma 1, 2, 3. Some quick note about the translate, right? If I want to do a translate, for example, here 015 to 012, and I put the result into some file, right? So I cat that file. This is the same file. Notice how it's the same file. All right. I'm reading, then writing to the file. This is not exactly okay because you're reading and modifying the same file at the same time, which should happen first, right? You're reading that, then you do the translate, which means you're modifying the file and then write it back. So what you want to do is do the first read and put that into the temp directory. Then you write it afterwards. You stage them by first read and translate. Put that into some temp file, then you write the location back to the original file to ensure that the whole thing finished before you overwrite the file. To make sure the command finished before you overwrite the same file. So that's more reference of regular expression. We will do this on task 1, assignment 1. That will actually make a lot of use of regular expression. There's many links here on how to use RegEx. Now we're gonna transition to Git. So in the meantime, let's do a maybe 10 minutes break because we're gonna switch here and talk about one of the tools that is really, really useful for your assignments and also for any future assignments. All right. Out of curiosity, how many people use Git before? All right, 1, 2, 3. Awesome. Actually, much more than I expected. I was expecting none, but this is a really good thing. Let's resume and talk about scenario. For example, let's say you're working on a group project and trying to cram the code in, and everything kind of works, and then you accidentally type rm-if store because you don't have a lot of sleep. Fun. Yeah, everything is gone. You don't have the recycle bin as well, right? It's text-based command. It doesn't go to recycle bin. Actually, what happens when you do delete something in Windows and it goes to the recycle bin? No, im-rf will not ask you anything. F is force, means that force remove everything. Yeah, recursively as well. Recursively means that if it's a directory, delete everything in it. So, yeah, as you hit enter, you're like, no, right? One thing you can do to fix this, archive it, like have a script that backs things up periodically. Another solution is to use version control. You might also, hopefully you never use this as a reason, like I swear my code worked yesterday. Yeah, but I wasn't here yesterday. I should have deleted, I should not have deleted or rewritten my code. My computer crashed. I lost a lot of my work. My cat ate my homework. I work with a friend. He accidentally. If you have a friend like that last bullet point, you should consider your life choices. But yeah, so these things hopefully doesn't happen to you, right? But if it does, these are software that will help at least protect like against these kind of cases, right? Let me ask you this question. What would be the most primitive form of version control? How many people save file into multiple versions when you do programming and you're not sure whether whatever you're trying to do will work or not? And you have like a version 1, version 2, version 3, version 4 copies of the same file, right? What's the downside? What's the downside of just maintaining multiple copies of the same file on your computer? Space. Obviously, you have to, each copy will consume space, right? Also annoying because you don't know, if you want to go to specific version, how can you tell which version you should try, right? I want to go to this particular edit. Is that version 1 or is that version 3 or is that version 5? I don't know. At some point, let's say 1 week afterward, you came back to your code, and like, I don't understand what I did. I lose track, right? So those are some possible downsides. And that's where the version control system comes in and hopefully fix many of these issues, right? First, version control system is supposed to track all the changes and allow you to go back and forth in time. You can revert back to version 1, to version 2, to version 3. On top of that, the version is done for each of the file. So let's say you have big projects that contain multiple files, right? In that way, you can revert the version just for one file, not all of them. Also, this is quite handy when, like, let's say you work at Google and you are basically trying to finish a project assigned to your team. But then the project rely on another piece of software developed by a different team, right? There might be bugs in that team software. So what you want to be able to do is to see who make that changes, because you want to make sure the whole thing is correct, right? This allows you, first of all, contact the right people that make the changes. Like, hey, what do you do here? Why do you make the change? And how do we fix it together? It also can allow you to see who contributes to what part of the code, so that if you have questions about certain part of your code, you know who to ask for, right? Because if you're working in a big team or in a big company, that will happen. And these are really, really popular, actually, version control system. And one of them is actually kind of almost win out right now, which is Git, right? That's why I asked how many people use Git before, because today we're going to focus on Git. The concept for each of this is kind of similar. It's kind of similar, but we'll focus on Git. So Git is a distributed version control system. When I say distributed, it means that you can have multiple machines, like multiple computer and desktop that have a copy of the project. And each machine has its own local version of the copy. I can make local changes. And at some point, once I say, hey, this is good enough, I can push it to the server so the server now has it. I can maintain multiple copies on many machines. And one nice thing about this, right? I don't have to connect to the internet. I don't even have to talk to the server to edit anything. Everything is now on my computer. I can make changes to the local file, and then all the history comes with it. I can revert back and forth in time locally without connecting to the internet. Yes.
How that doesn't waste space.
Great question. That's an awesome question. So Git do this, right? So let's say you have file one. Let's say I have a code name file 1.c. You first initially you store the file, so it will definitely have to maintain the base code, right? Then what it does is store the differences between each version. So if it doesn't have a lot of edits, like let's say in the file it has 1,000 lines, and you make modification to like 20 lines, it will only lock those 20 lines, or actually not just 20 lines, the character that have to be replaced. That's it. So it doesn't store a snapshot of each file, but it stores the difference between each version. So that way, the amount of data you have to store is going to be gradually changing. There are some trade-offs. For example, let's say you have an image file, right? It's not like you're going to edit the image file and they would look the same. The raw data in the image file is going to look different. So when you update that, it's going to be a totally new file. So Git will actually pick which one is more efficient, either the diff compared to the earlier version. So it will just store the differences, or a totally new file. But yeah, that's a great question. That's actually one of the benefit in using Git to store code and programs, because in many cases the base code will look almost the same. Then you just track the differences. And this allows like a really, really good balance of collaboration, because you can sync with your friends through the server, or working from home and not having to talk to anyone for like 2 days until you say, hey, I'm ready, I can push this to the server. So Git is again probably right now the most popular distributed VCS. The benefit is I can branch easily, I can merge things easily. It has a really flexible workflow. How you operate Git is pretty simple, actually. It also checks for data integrity. It means that when I update my code with the server, it checks if the file you got is correct or not. And also really fast. It's performed well. It's actually space efficient. It doesn't really load out your disk when you have to maintain different versions. So to actually understand it, right, I have to define more things. First is repository or repo. Repo is a collection of files. Think of it as this is the base directory for your code, for your project. And then file history will appear in the snapshot. Think of it as, let's say, I assume that many of you play computer games or console game, right? When you play the game, you have the ability to save the game. And when you save the game, it means that you can come back to the save point and load that in any time you want to. That's a snapshot. That's a snapshot. Basically, you take a snapshot of your progress, then you can keep going. But if something turns bad, you can come back and load this snapshot. We call this a commit. Commit means I will create a snapshot that I can always come back to. A repo can also have different branches. Sorry, this thing is coming out all the time. A repo can have different branches, each with their own history. So I can branch out into multiple sub-projects. We will cover branching in a bit, right? But your concept right now should be, I can keep track of version, and then I can branch out in a way that each branch has its own version. So when I said version is something like, let's say you have 3 files in the repo, that's it, you have only 3 files. Each version will store just the difference between the original file and where we are right now. So when you have to go back, you just undo the change. You just undo the changes here, which will allow you to go back in time, reapply the change to go forward in time between each version for each of the file. For each of the file. Each version here will have a commit ID. Commit ID that you can refer to, because that allows you to go back, say, hey, I want to go to this ID, I want to go back to this ID, I want to go back to this ID. That allows you to identify where you want to go back. Then you can create a new repository using the command git init. This will create a blank repo that you can work with. That's a blank repo. Let's say instead of a blank repo, you have a code that you work with your friends, or it's a starter code for your project or something, or it's like a project at the company you have to work with. You can clone the repo using the command git clone with the repo name. This allows you to clone a remote repository into your local location, basically your laptop, your desktop, that you can, so that you can work on it. And high level principle of the things you can do is, this is your directory. That's where you are. And that's a file you see right now. We call this a sandbox. It can contain file that's not a part of the repo. It will also contain file that's a part of the repo as well. It contains everything. Then you can propose a commit snapshot. We call this part, we call this part the index. The working directory is like, I didn't save it. Index means that I'm proposing this as a possible snapshot. I'm proposing that I'm gonna take this snapshot. Then head means that that's the last snapshot, basically last save that you've done so far. You can always go back in time before this, but head means that that's where the last commit happened. That's where everyone who shared the repo will see. Now, let's say you have file A in both head and index, and you basically modify this file. File A used to be in the index. This is like the version that everyone sees. And yes.
So when you commit index, it becomes.
Basically, yes. When you commit, index go to the head. Now, let's say you just modify the file right now. Becomes version 1 becomes version 2. When you change the file, it's going to be in the working directory. It's not going to commit. It's not going to be commit yet. It's not going to be even tracked. To first track the change, take it add with the file name. This means that this new version will overwrite the old version, version 1, at the index, but not at the head because you haven't commit yet. Then you can commit the change by saying commit. It will also ask for the message. This is useful for you to tell your friends, what are you doing with this commit? For example, I can say file A version 2, I modify this function to build this feature in. Now this part works, this part is still not working. I can put that in the message and commit everything together. The version 2 will replace version 1 in the head. Now everyone can see. You can also see this. And now you can go back in time. This becomes like a snapshot. Once you commit, that becomes a snapshot. If you want to undo, so this is staging. This is commit, right? Only this part becomes a snapshot. Staging means I'm preparing this new version as a potential snapshot. So if you say, hey, yeah, I know I'm preparing version 2 as a potential snapshot, but something goes super wrong, I want to revert back to version 1. I can use the command git reset to reset the file back to version 1. If you want to throw away all the changes, now that I want to make sure the working directory, the file I see is version 1, add -- hard, it means that it will delete all the things you do in version 2 is gone. Now your working directory will have the version 1. You can use git status to keep track of files that are not tracks, files that are staged but not commit. So over here, it would basically tell these are changes to be commit. You say, hey, this has some changes. You should commit them if you want to make sure everyone sees this change. These are files here modified, right? That are not staged for commit. This is untracked. It will also say, use this command to do what? All right. Any questions so far? So first of all, I noticed quite a bit. Toward the end of today, I will basically let you know what are the common things I do. Common practices, which kind of boil down to like 4 commands to do the whole thing. All right. So now let's talk about branching. So let's say you are running a startup company and you have to manage like 2 teams. One team work on one feature 1. One team work on feature 2. And this is like a public version that you are selling right now. Basically, you're selling that public version. Everyone see it. That's a stable version. Everyone can use it. Then on the side, you have 2 teams on your company working on 2 features that eventually will be merged to the public version. You can use branching for that. This allows you to branch a code for the first team so that they can implement whatever feature 1 does and then merge them later. Also, you can branch into another branch for the second team from the same base code so that they can work on 2 separate things. All right. So to switch between each branch, right? So now let's say the head is at the master branch. To go there, you can do git checkout master. Checkout allow you to go to that particular version, that particular branch. So in this case, git checkout master will go to the master branch at the head. If I want to switch to branch 1, I can do git checkout branch 1. This will switch to branch 1. Then I can create another branch by git checkout -b branch 2. This allows me to switch to another branch 2 from where you are. Oops, sorry. So here, right, when you do checkout master or checkout another branch, basically what will happen is if you check out master, you basically jump here to the version that the master branch will see. When you do git check out another branch, basically what will happen is every single file will first revert to here, then you apply the change here so that you can be back here. So the first thing is I revert the change to the merging point, right? And then I apply the change into the new branch. This allows you to quickly switch between 2 branches and your code will be updated. Everything is done internally within the Git system. You don't have to do anything except for making sure the version is correct. Now, Git also works with the server. For example, anyone know the website called GitHub or GitLab? So these are the two probably most common platform that you can use to maintain your own code repository using Git. This allows your code to be on the GitHub server, for example. When it's on the server, it's a remote location, right? Basically, the code is on the server. I can have the code clone to my laptop. And let's say I am at home, I can also have the same code clone to my desktop. Now, both laptop and desktop are cloned from the same part. I can make changes and then basically push my changes to the server so that everyone else also see the update. So here, when you work with the server, right, the first thing that you might want to do is, I want to update my local code to be the updated version on the server. I can do that quickly using the git pull command. Git pull will apply all the updates the server have onto your local code. So now your local code is going to be updated with the server's update. So the quick overview is, let's say originally both your version and the server is the same, but now the server keep going ahead, right? You haven't edited anything on your laptop for a while. Someone makes some changes on the server. Now the project is updated. What you can do is to use git pull. So from this version, git pull will make sure that your version is now updated and be at the same point with the server again. All right. The next thing is, let's say you're updating your code and you want to push the change to the server so that everyone else see your change. You can use git push. Basically, this allows the reverse of the information, basically now from your desktop to the server. So here, right, before pushing, the server is behind you. The server is behind you, you have new updates. You push, the server will be at the same point as where you are. And the workflow is basically, well, actually, I'll just circle what I use a lot. All right. Typically, I will use git commit -a. This combines git add and git commit together. So you go from your workspace all the way to the local repo, to the head. Then if I want to update the server, I do git push. So I do git commit followed by git push. If I want to update everything from the server, I do git pull. And then at the beginning, I do git clone. All right. So the last thing about Git, so with this, right, I'll show you some demo at the end of the class, but let me continue with what if the project is a pair project. You're working with your friend. You're working with your friends. You make some edits. Your friends make some edits on their local laptop. So you have the new update on your laptop. They have update on their laptop. The server have the old version. No update has been applied. Both of you want to push to the repo, right? What's the problem? So here's the server. Server has version 1. You have version 2.1. Your friend 2.2 is spawned from version 1. So you don't see your friends change. Your friends don't see your change. The problem is, if both of you want to update the server, how are you going to merge the two together, right? Because at the end of the day, there are two different edits to the same code base. All right, we call this a merge. So let's say you push to the server first. The server will be updated from version 1 to version 2.1. Then your friend who has the version 2.2, when your friend is pushing, they will have to resolve the conflict. They'll have to make sure that after the merge, everything is correct. So before merging, there are two merge that can happen. Let's say before merging, the master is behind the new feature you want to add in. And only one is making changes right now. This is simple. We call this fast forward. Fast forward means that, well, there's no more changes. I'll just fast forward where I am to this new feature, and everyone will see the most updated version. That's it. Now, here is where things get a little bit more interesting. This feature branched off from this version. Someone makes changes and use the fast forward to go there. So now you have the old version with some features and the new version without that features, right? It means that if you want to combine the two, first of all, this thing has to go to your code. And then you have to make sure that whatever is applied here also remains there, right? That's why we call it three-way merging. Basically, what most of the time, what you have to do, it will tell you for these files. So let's say you have file A. And let's say both of them have some conflict on file A, like some feature make changes to file A, and the master also have modification to file A, and there can be multiple lines that get changed, right? What Git will tell you are the file that has a conflict. It will basically tell you, go fix this file because I don't know how to merge. And you as a programmer basically open the file, modify it to the final version and say, hey, that's the final version, that's good. And then you push. After you push, basically you would then merge everything into one single point in time again. So again, the command are this. That's it for Git. All right, that's it for the lecture part of Git. The quick thing, homework one is out. And then we have the in-class exercise. I want you to try LeetCode and go to this link. It's gonna open up the exercise that you can do on the website itself. You don't have to do that on your machine. What the exercise asks you to do is you have an input, you get just the 10th line, and that's it, that's one line. That's why it should be pretty simple. So this will be first also intro to LeetCode, which we will use more for the C assignments, for the in-class, and also for the playing with shell